So either we can, in tomorrow's lecture, we can continue to discuss more about optimizer, or I could pick up a problem for data dictionary. Data dictionary is where all the metadata for RDBMS is stored. Okay, that is a very important aspect that you want to be exposed to. So we have two ways. Either that becomes an exercise later on next week, that you guys try to solve a problem on data dictionary, because that is one thing you should use. That is, as a programmer, something you have to be aware of if a client says my query is running slow. Okay, that is what explain plan utilities and data dictionary utilities you'll use. So does anybody have a feeling one way or the other that one is we can continue to do chapter 14 because it'll follow in the sequence of text. It'll make reading much easier for you guys. So you'll know what this text can offer you later on. Or we could go for an exercise tomorrow.
So is 14 just more query optimization?
It is more into...
13 is the beginning of query optimization?
Yeah, that is the thing. And I don't know why he broke it up into two chapters. And at certain point it becomes redundant, because all you are doing is, okay, let us change the plan in this way and do the cost. Okay, so instead of having a lecture on it, you would rather have an exercise on it. You know, there's no point in, again, me drawing one plan and say, okay, it'll have 10 reads here, 15 reads here, and that is what I feel. I just find it redundant. Please give me your feedback, because I want tomorrow's lecture to be used well.
Is this query optimization in the sense of what the DBMS does to your queries when it gets them, or is this in the sense of us writing better queries?
Okay, one is to understand what DBMS does. So when the query hits a DBMS, it is going to look at all the different possible plans. Okay, for the same query that you have written, it is going to have 15 different plans of execution. It may do a projection before it. And so today's lecture is reasonable. It is short, but it is good because it still exposes you what are the other things that RDBMS uses to, say, move the projection up or low. Conceptually, you know it, that yes, do a projection before you do a join. And so that is when I feel, because you guys have written the queries in a month before, and we have gotten the queries, ideas introduced already, you know how to calculate costs of queries, you know how algorithms are written up. So I want to use tomorrow's day better. So if you have any feeling one way or the other, it's fine. Otherwise,
if we don't do the data dictionary tomorrow, is it not going to be covered?
Huh?
If we don't do the data dictionary tomorrow, is it not going to be part of it?
No, I want it to be covered. Okay. I really want it to be covered. I wrote this problem set on data dictionary for evaluating programmers at AD itself.
Okay.
And we made them do, you might have heard of one of our projects. Are you recording already? Oops. Okay.
Yeah. I can take it out anything out.
Okay, thank you. That helps.
$20.
They don't think much of me.
No, it's a very good exercise that makes you think more about how to write good reports, because if you go into somebody else's database that you have designed, somebody else has designed, and you go in, you want to find out where are all the constraints that this guy defined. You can't keep on going into every table and looking at what is the definition of the schema, and that is where the metadata becomes really important. You can go in and query this either, so there are prefixes that there are like user, DBA, and all. So these are different tables that are in the data dictionary or metadata for your database. Is you can say something like select constraint name from should be here. from all, I think it is constraints, all constraints. These are, I'll give you the exact, because every DBMS has its own names of the tables that go into metadata, which will store its constraints. Then there are user constraints, DBA constraints. Depending on, these are classified on the scope. Who can see what? And from all constraints where user is equal to Joe or something like this. So then you know that, okay, I took over the project from this guy. I want to see all the constraints that he defined. So you can get a table name also here and constraint name also, so you know what is going on. So data dictionary gives you a very powerful view of the complete table space. And so I will certainly, if we don't discuss it, I would hand out at least the problem so you guys can read over it, because it has very good links to refer and understand data dictionary more. But that is again on Oracle, because we are doing it on Oracle. So it might become like a useful handout for you guys later on. So I'll pass that out irrespective. And you told me yesterday Wednesday is a bad day because a lot of people are leaving for.
I have no idea if a lot of people are. I'm just saying some people won't be here.
Okay. No, I just want to get an idea about how many won't be here.
I don't know.
You don't know. Okay. Problem. I just want to know, so we should pick up a topic for the day that people who are not here can do it by themselves also, if that handout is, that is how I want to use that day. That is why I'm asking if I can get a good feel of how many people will be here.
Okay. I ask people to tell me, but I've only heard from 12 people, so.
Okay. If you could, can somebody please find out for me?
Yeah, I'll let you know.
Okay. 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 Let's look at a few examples today.
Well, I want to put that past him, but nevertheless.
Okay, so and we can make that if everybody agrees, we can make Wednesday as the day when we can talk about data dictionary in detail. And I'll pass out the handout to people who won't be here in advance, so you can just look it over, find the relevant links, and maybe take out printouts to look at it.
Is there a syllabus somewhere for the rest of that?
Rusty has it. I thought he might have given you guys out. I really want to discuss, I can tell you. So on Monday, I want to make sure we go over normal forms. That is one big piece that is missing till now. After that, I had thought of giving an overview of transactions. How transactions, there are several things that are quite important when you go into secure, or I should say atomic transactions. And something I wanted to cover. After that, then
A lot of transaction stuff for what it's worth.
Yeah, we have.
you have
We
had
have seen. Yeah.
you've had a lot of
We
transactions.
have a lot of it in systems.
Doesn't mean it
Okay.
might be going over the
Then
very specific stuff.
okay, so then this is good you're telling me, because I'm not aware of it. The other important thing is then we can look at, suppose you're working on a database and suddenly you can't find any handles. What do you do? Okay, thinking about where the locks are happening. So I can go into like inside DBA, like database also. We could pick up some examples if you guys want.
Yeah.
If you haven't done that part, that you have, your system is being used by 20 concurrent users and suddenly you lose, people are not able to get database handles. Who's the user who's hogging all the resources? There could be these kinds of small things. We could discuss that if you want to. Is that better then?
Yeah, I think so.
Yeah.
Because after normal forms, I don't want to do any more theory. There is enough definitions have gone in now. I think we can. Is that reasonable? Then I'll try to, over the weekend, I'll pick up some. We have a quiz on Sunday. Everybody knows that, right? Okay. I'll try to pick up some examples for you guys. I'll try to pick up from what we have encountered at AD, like people have put in as knowledge objects for internal use, but I'll expose them as a tutorial because they are good. People have encountered small things, how to find deadlocks, how to look into your database performance.
Is there any luck with the big tables comparing queries for optimization project ideas?
Yeah, we are getting that. I got the document yesterday. I have to now reformat it so we can use it. Okay, I got the document, and that is most probably going to be your final exam exercise that you will get. At AD, it took us about six hours to finish that off. But in that, we had to write Perl scripts to scrub the data of 1 million rows, and that included that. So you won't have to do any of that because you'll be inserting your own data into those tables and generating those reports. I still told Shai that you should still get 2 full days. One is because you have enough time to go over the reference material and understand what you're doing. That's all. There's no point in
Database we'll be using to do this and whether we've used it before.
Oracle. Is everybody okay with Oracle?
We're okay with it, but none of us have used it really.
Okay, so that is when you will get 2 full days. I'll give you relevant documents to look at, how to use commands like explain plan. So you give it a query, and then it tells you actually what plan it is going to use, how many times what indexes it thinks are appropriate, and then you make, if you create an index on your table, then again if you execute the query, it is going to start. Suddenly now the metadata has registered an index on that table, and it may use it for the way you have written the query. And
That'll be like Thursday and Friday next week or
Yeah.
something? Okay.
yeah. Okay. 2 days would be enough, and you'll learn a lot. That is what I feel, that it'll converge a lot of things for a database course. Okay. All this discussion we have been having about performance may start making sense then. Then you'll see the numbers, that yes, it did hit the disk so many times. It had to go and change things. Okay. Okay, what are the jobs of a query optimizer? Find an evaluation plan. And calculate costs. Okay, so we have, in a sense, we have understood how to do all 3 of them for different queries over the last 1 week that we have been looking at and using different examples. So I will use the examples that that the book takes, because it gives you 2 ways of evaluating queries. So the query that is there is again select Okay, so in relational algebra, I will write it. I should just draw the tree. We don't need to write it in relational algebra. Okay. So now so once we have defined an algebraic representation, the next part that a query optimizer has to do is tell it how it is going to do these steps. Okay, so there are two ways to do it. One is pipeline evaluation of operators, of the operations, and materialized. So for instance, if we have a lift, this is our operator here, and it is going up, and then we have something right here. Okay, if the result of this operation is written in a temporary space, then it is called materialized. If it is not written, and all you do is you fetch the results here, suppose here also, let us just give an example that there's another op prime here, and so this operator did something, and all these results, either we can write these results into a temporary space, say T1, so there's another relation that was written up, okay, then it will be called materialized. So there'll be an extra cost associated with it, okay, because you'll have to write to the disk, and then again you'll have to read it to use it. Okay, if you feed it directly to this as you get this, so this node, whenever this node requests data, this passes on that data, it gets processed, whether it is going to be written or rejected, accept or reject. Once this processing is completed, then it requests the next one. That is called on the fly or pipeline evaluation. Okay, and in this you do a writing. So if you conceptually think of why would anything use this against this, is every operator has its algorithm in the way it is going to work. Okay, every operator has an algorithm of implementation. If that algorithm needs to access this data multiple times, then you want it to be materialized. Okay, so depending on what kind of algorithm this query optimizer is going to decide for your operator to use is when it will have to decide whether I should go into temporary relation or not. Okay? Okay. Okay. So you will see whenever this is written is, okay, you don't need to save this, so this will be represented as on the fly. Then this is comparison, this is going to be scan. Okay, there's a file scan associated with this. Okay, then because this is a comparison, you don't need to, is it going to be sorted here? So this is not going to be written up because it is comparison, so it will be on the fly. Okay, so and then there'll be whatever, whether it is simple, nested loops, or whatever is the implementation algorithm for join that is being used is going to be implemented here. So this then becomes a representation of what query optimizer eventually decides that, okay, now I have decided how each of these are going to be implemented. Okay? Why would join be materialized?
No, I don't think it's necessarily it should be. It is like
No, it is an implementation. What algorithm you're going to use for this?
okay, but it's I'm just not sure why. So it's on the fly too. Or?
Yeah. So what you should do is when this join is being made is when you start pushing it up. So this operator then has to request the results of this join.
Yeah. So nothing is saved.
exact, till it comes into here. Because that is when your results get written up.
Okay. So the join is also on the fly?
Yeah.
It's not?
Yeah.
Okay.
In this case, yes. I mean, depending on how you implement it, because you can, the other way to think of it is, which I'll go in next, is you might want to move these down here. So before you do the join, you actually do your selection. Okay, so you have much smaller data set. So these things are what Query Optimizer is going to look at. And okay. But for each of these, then it has to think whether it needs to, the algorithm that is going to implement the next operation, does it need to go over the data again and again? If it needs to go over the data again and again, then it is going to materialize it. Okay?
But in the case where we've got extremely large data sets where the join's going to produce more pages than our buffer space is available, we're going to be forced to materialize it.
No, because it depends on how you'll process. You can process tuple by tuple. You can process page by page. It is your choice. So you don't have to. You're not pulling up everything in the same area.
Okay.
So you could. So this operator could actually say, okay, now give me the next page. I'll process the page. Okay. So depending on how I'll go. Again, that is why I'm saying these are all options that DBMS decides how to do it depending on all the parameters that it has. Okay. Actually, the question that you asked, there is an example for it, which is very good. It just answers that specific question you'll see in the book when you'll read it, because it actually compares the cost of going processing tuple by tuple to page by page. Okay, depending on what the implementation of this operator that is requesting asks for. Okay? Okay. Now let's get into, it is called iterator interface, because you have to go over either number of pages or number of tuples, whatever is going to decide where you are in the, so you start processing, say this one, and you requested the first page here. Something has to keep track of where you are here and what is the corresponding page here that you are working with. Okay, so all these counts that are, or I should say tracking that is done through the functions that are provided by the iterator interface. So you have functions which are open, then you have get next and close. So open is going to initialize, it has to allocate buffer, memory. Then get next is going to go for a loop and keep track of place, and this is going to deallocate the space that is associated with this. Okay, so these are the functions. So what an iterator interface gives is a set of functions through which you can access these things, and it just hides the implementation of everything. Okay, and this is again not at a user level thing, because this is what is happening is at much lower level of implementation of this. You will never call get next or iterator interface. Okay. Okay. So regarding the optimizer, R will decide. What I'll do is then tomorrow, why don't I pick up parts of chapter 14 which I feel may not be overlapping with what we have done. If it can go into specific things that are being used by DBMSs today that have evolved over time, then I'll. The problem is that none of the companies will ever release what their optimizer does. Never. Because that is the heart. That is the heart of the whole thing. And I think this author had no other choice. Probably this was the only optimizer that was the first one. So the first one is always open, and then they didn't realize the importance of it.
It's like the System R thing, which is from the 70s.
Yeah, and that is the only one that is available for you to look at.
Run out.
I'm sorry?
What about some of the open source databases?
I don't know, how good are they? How?
The authors don't mention PostgreSQL or anything like that anywhere. So
My question is how, because you guys have used Postgres, how is query optimization, how good it is?
well, we've
You might have read, or have you,
data
no,
load heavy enough to.
certainly. I'm just wondering, have you, this would be interesting. If we get that exercise in a shape that we can, and I think I will be able to get it, that some people should do it on Postgres. That would be very nice.
I'll do it.
Just to see, really, just to see that it'll become an internal thing to compare for us.
Yeah, that would be valuable.
Yeah. Okay. Good. Okay. Then the important part is system catalog. That is what is called data dictionary in Oracle. And this stores all the metadata about your data. Okay? So for example, you can pick up all the, so there is a table space. So let me go ahead. So you have, say, select owner from all tables where user is equal to Joe. Okay, so you can actually start looking into and finding out that what all different tables, indices, constraints he has ever defined, and you could start working on some of these. Okay, so we'll go over this as an exercise in detail, and I'll have this for you guys. But system catalog is very important, and I don't know in which they would. He doesn't. Does he mention any other name for it? Maybe every database has its own name of calling it. Do you know what is in Postgres? What is it called? The metadata? Okay. Try to look into the documentation. That would be useful if you are thinking for a project on Postgres. Okay. Same way, there is a table called all constraints. And you can get all the constraints defined by this, and you can either give it the table name here. Instead of owner, you could just say table name. So you can, at least whatever is your project that you're working with, you can start getting more information about. Okay. Okay. Let's do one more example, and then I think. So the question of that you asked about, and where I alluded to pushing the selections above and below, and that is what is called. There are two types of selections you can do. One is by pushing the selections. So another way of this is. I'm taking this from an example that has in book. So it has two parts that you can improve performance by pushing selections, and second part is by using indexes. And I'll have Dimitri take care of the indexes because I'm trying to find another problem for him to discuss this during recitation. But let's look at pushing the selection. So pushing the selection would mean, because this boat ID and ratings, they are specific to these tables or relations, we can move them down. Okay, and so what is going to happen is, if we just use the nested loop joins, so I should rewrite the query from, does anybody have a book? I'll just rewrite, I'll draw the query again, and just make it simpler. So we have the selection. Oops.
Sometimes, not always. Okay, so that's right.
Well, I don't know, might not apply here. There's no lawsuit now.
Oh, that clustered sorting.
Check what is green. What is green?
The single green in the book.
Something good.
Something good if it's in the lawsuit. This is
Group by, I guess, and having clause.
Very interesting. So do you read the red ones again and again till they become green, or?
That's right.
Gradient, yeah.
Are those stolen office supplies?
She's a partner. So you're not really stealing her.
Oh, yeah. That's right. This relates to work.
Is this a common lawyer thing?
I don't know. Some of us are more compulsive than others.
Yeah, Joe, do you have posters on your books? I guess it is common.
But with your legal brief, you do that not public thing?
Thanks.
The messenger's
Okay.
desk is a secret organization.
So let us write the assumptions.
Joe cryptography. I've got my own version of that. Mine's new database.
Join by sort merge algorithm, and we are using a number 5 buffer pages. Pages to estimate the cost. Estimate and even distribution of boat reservation, and ratings vary from 1 to 10. So these will be our assumptions for doing this evaluation. And I think our R had 1,000 pages, right? R had 1,000 pages with 40 bytes, right? That is how it became, and 100 tuples on each page. Is that, or do I have it wrong?
Is it 50 bytes and 82?
So then it is 50, 500, 50, and 80 here. Okay. Okay. So first we'll do a scan. So our cost for the scan would be 1,000 plus 500. Okay, because we are doing a simple scan. Next would be, so we are going to do a selection, and in selection So we have 1,000 pages, and in 1,000 pages we have even distribution of, so there are 100 boards. 100 boards, and so we will have how many? 10 pages then, right? So 10 pages per board. So we are going to cost for writing, say temporary relation here. T1, what happened?
It's just a funky boat club.
Okay. So once you have written that down, on the other side, it is going to be, because our ratings are evenly distributed, right? So the ratings would be, we'll have to write 250 pages, right? Because if we have a scale of 1 to 10, half of them will be below 5 and half would be above 5. So we'll be writing for T2 here 250 pages.
Robbie, did you know that a number of students have actually joined a boat club so that they can practically understand
if we can actually have a AD Uni sale, then we can.
They join community boating.
Unfortunately, it doesn't work though because they don't take reservations for boats.
It was all for naught, wasn't it?
Okay, so now we have the sorting cost. Then again we'll have that 2 times n. Right. And so how many buffer pages we have? So 5. No, buffer pages are 5.
Oh, five,
Yeah. So 5 buffer pages. So our 2 times n is going to be for this 10, and log b minus 1 would be 4. N1 is going to be 2. So N1 equal to, for this case, N1 equal to 10 over 5. That is equal to 2. So this becomes 1. So we get log 4, 2 plus 1. That is equal to 1. So we get 40 page.
How many buffers did we say we've got?
5.
Okay.
Okay. So let's do the. So we'll have sorting cost of 5 for the first one. Sorry, 40 for the first one. And for the second one, then we are going to have 250 pages, right? Pages, so N1 equal to 50. Yeah, and log 450 is going to be 1664. So 3, right? And so our sorting cost is going to be 2 times 250 times 3 plus 1 equal to 4. That is equal to 2000.
You just estimated that 250.
No, because we, so our ratings are between 1 to 10.
Right.
And we want to select less than 5 or greater than 5, so it'll be half of the pages would, on an average, fall into that category. So I just divided that by 2. Okay.
Why is the N1 50? Not the 250.
Because it's 250 divided by 5. Which is the buffer.
5 buffer pages.
So pass 0.
So N1 is
Pass 0 would 2000, and then merging. PT1, what is T1? 10 plus 250. So what is the total that we get? 260 is 520. And this is 1500, 3500, and
4,060.
Is it? Okay, I'll take it. Yeah.
Oh, no, what's the 10s? 480.
No, I think
Oh,
the
okay.
tens
Okay,
are added.
yeah,
That's
yeah,
fine.
that's what-
That's fine. Yeah. That's fine. Okay. So this is the cost when we project our operators. I'll just do one more, which is if we were using, instead of sort merge, if we were using the block nested loop, Shai covered all these algorithms, right?
Yes.
Right, all of them. Oh, Rusty also. Shai didn't cover in the sorting. I think he should have. He should have started off there probably, and costing was done in.
Rest is the join method.
Oh, okay. Join method. Okay. So for block nested, we out of 5 we basically are left with 3 because 2 we have to reserve for input and output. So we have 3 buffer pages effectively. And out of this, then, because we had T1 equal to 10, right? T1 equal to 10. So we will be able to cover it in 4 times, 4 sets of 3. We'll be able to cover our T1 groupings. And that will correspond to as many reads of our T2. So our cost should be then 10 plus 4 times 250. Because T2 is 250, and so this is the as many times you'll have to do it. Sorting and writing.
Oh, that's a plus.
Oh, I'm sorry. You're right. Sorry. So this is reading the 10 pages, and this is the grouping of 4 times 250. Okay. So one last point is using the same thing by index, and Dimitri will cover it.